The bright red star in the constellation Orion has long been a source of fascination for astronomers, and for good reason. This massive red supergiant, situated around 650 light-years from Earth, is a cosmic titan in every sense. Betelgeuse is visible with the naked eye during winter in the northern hemisphere, and its reddish hue sets it apart from other stars in the sky. But what truly makes Betelgeuse intriguing is that it's a ticking cosmic time bomb, a star nearing the end of its life, destined to one day explode in a supernova. This cataclysmic event could, according to some experts, occur far sooner than previously thought. The recent strange fluctuations in Betelgeuse's brightness have fueled speculation about when its explosive end might happen and what that might mean for us here on Earth. The sheer size of Betelgeuse is astounding. In terms of volume, it dwarfs our Sun, which, despite being massive by terrestrial standards, is modest compared to other stars in the universe. Betelgeuse is estimated to be roughly 800 times the diameter of the Sun. To put that into perspective, if Betelgeuse were placed at the center of our solar system, it would stretch out beyond the orbit of Jupiter, enveloping Mercury, Venus, Earth, Mars, and the asteroid belt. This colossal size also means that Betelgeuse shines with an incredible brightness, up to 10,000 times that of the Sun. It's so luminous that it can be seen clearly from Earth without any assistance, even though it is hundreds of light-years away. This visibility speaks to the powerful radiance of Betelgeuse, which is due to the fact that it's in the late stages of its life as a red supergiant. Red supergiants like Betelgeuse are known for their instability. They expand and contract in cycles, which causes changes in their luminosity. For Betelgeuse, this fluctuation occurs over roughly 270 days, with its brightness waxing and waning as it pulsates. However, these normal variations took a dramatic turn in late 2019, when Betelgeuse's brightness dropped suddenly and significantly, reaching only about 40% of its usual luminosity by February 2020. This event, which has since been dubbed the Great Dimming, was unprecedented in the star's known history. It immediately sparked intense interest among astronomers and even led some to wonder if Betelgeuse was on the verge of going supernova. A supernova is the explosive death of a star, and for a red supergiant like Betelgeuse, it's the final stage in its stellar evolution. In general, massive stars end their lives in supernova explosions after they have exhausted their nuclear fuel. As they reach this point, their cores collapse, releasing an enormous amount of energy that ejects the outer layers of the star into space. This process is extraordinarily violent and releases more energy in a few seconds than the Sun will emit over its entire 10-billion-year lifetime. For Betelgeuse, an eventual supernova is a certainty, but the timing of this event remains uncertain. Some astronomers estimate that Betelgeuse's explosion could happen within the next 100,000 years, while others think it may be as far off as 1.5 million years. In either case, it's a relatively short time by cosmic standards. The unusual dimming episode in 2019 initially led to widespread speculation that Betelgeuse was in its final stages, ready to explode. But further investigation in 2020, particularly through observations from the Hubble Space Telescope, revealed a different explanation. The dimming was actually caused by a massive cloud of gas ejected from Betelgeuse itself. This material then cooled, condensed into dust, and partially blocked the star's light, creating the illusion that its luminosity had decreased significantly. This dust cloud essentially formed a cosmic veil between Betelgeuse and Earth, making it appear as though the star had lost a large portion of its brightness. Once the cloud dispersed, Betelgeuse's brightness returned to its normal levels. The explanation for the Great Dimming satisfied astronomers temporarily, but Betelgeuse has continued to behave unpredictably. Since early 2023, the star has been shining even brighter than before, raising more questions about its stability. Some scientists believe that these fluctuations are related to the late-stage life cycle of red supergiants, which tend to exhibit irregular behavior as they approach their end. However, others suspect that Betelgeuse might still be hiding secrets about its inner workings that could further inform our understanding of stellar life cycles and supernova precursors. When Betelgeuse does eventually explode, it will be an event of cosmic proportions, and one that will be visible from Earth with the naked eye. Some scientists predict that the supernova could be as bright as a crescent moon, while others suggest it could rival the brightness of a full moon. The light from this explosion will be visible in the daytime sky, and at night, it will cast a glow over the landscape, offering a rare spectacle for humanity. The sight of a supernova in our night sky would not only be awe-inspiring but would also serve as a stark reminder of the incredible forces at work in the universe. Despite the breathtaking nature of such an explosion, it's unlikely to pose any threat to life on Earth. One of the primary concerns with supernovas is the gamma-ray burst that accompanies them. Gamma rays are highly energetic forms of light, and if a supernova were close enough, the gamma rays could potentially damage Earth's atmosphere and even lead to mass extinctions. Fortunately, Betelgeuse is far enough away that its gamma-ray burst won't have a significant impact on our planet. Additionally, Betelgeuse's axis of rotation does not point toward Earth, further reducing any risk to our planet from the explosion's radiation. What remains exciting is the possibility that we could witness two distinct flashes from the Betelgeuse supernova. After the star's core collapses and the initial explosion occurs, the ejected material may collide with the surrounding shell of gas that Betelgeuse has previously expelled. This secondary collision would create another bright flash, visible from Earth, adding to the spectacle. The result would be a rare double feature in the night sky, offering scientists and stargazers alike a unique chance to observe the complex dynamics of a supernova in real time. After the supernova, Betelgeuse will likely leave behind a neutron star. Neutron stars are some of the densest objects in the universe, formed when the core of a massive star collapses under gravity, packing mass equivalent to the Sun into a sphere only about 20 kilometers across. This stellar remnant would be much smaller and denser than Betelgeuse but would still carry a significant legacy of the red supergiant's mass and energy. Neutron stars are also known for their rapid rotation, with some spinning hundreds of times per second. While Betelgeuse itself does not currently rotate at such a high speed, its rotational speed has puzzled astronomers. Betelgeuse's rotation rate is unusually fast for a star of its kind. Observations from the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile have revealed that Betelgeuse spins at a speed of about 5 km per second, which is roughly 50 times faster than what would be expected for a red supergiant of its size. Normally, stars slow down as they expand, but Betelgeuse's rapid rotation is an exception to this rule. One possible explanation for this anomaly is that Betelgeuse might have merged with or swallowed a smaller companion star at some point in its history. If a smaller star was absorbed by Betelgeuse, it could have transferred its angular momentum to the larger star, effectively spinning it up to a faster rotation rate. This process of stellar merging isn't rare, as massive stars often interact with nearby companions, especially in binary systems. Another possible explanation for Betelgeuse's fast rotation is related to convection currents within the star. Betelgeuse's surface is covered with massive convection cells, regions where hot plasma rises to the surface, cools, and then sinks back down. These cells can create shifting red and blue shifts in the light emitted by different parts of the star, giving the appearance of a rotating surface even if the star's core isn't rotating that quickly. If this is the case, Betelgeuse might not be spinning as rapidly as it seems, but instead, the convection currents are creating a kind of optical illusion. Further high-resolution observations from ALMA and other telescopes are expected to help clarify this mystery. In the grand scheme, Betelgeuse's future supernova, whenever it occurs, will offer an invaluable scientific opportunity. The explosion will provide insights into the life cycle of massive stars, the mechanics of supernovae, and the formation of neutron stars. It will also remind us of the ever-changing nature of the universe. While Earth won't face any immediate danger from the event, the explosion will be a poignant reminder of the scale of cosmic forces at play around us. Thank you for joining us on this fascinating journey into the cosmos here at Space Lab. We're dedicated to exploring the mysteries of the universe, uncovering the wonders of stars like Betelgeuse, and keeping you updated on all things space. Be sure to hit subscribe and stay tuned for more thrilling discoveries and deep dives into the endless beauty and complexity of our universe. Until next time, keep looking up.